Hello, everyone. Good morning, good afternoon, depending on where you are. And welcome to the second installment of the Unravel Optimize webinar series. So I'm Sarah, and today I'll be joined by Patrick Mawyer, Solutions Engineer here at Unravel. And today he'll be discussing accelerating performance for Databricks. So before we start, here are some quick housekeeping rules. So first, if you have any questions, feel free to pop them into the questions box, and we'll either answer them live, or if we happen to run out of time, we'll reply by email. This webinar will be available instantly on demand shortly after. So if you have to drop off for any reason, feel free to come back to this page and listen to it at your leisure. Lastly, let us know what you think about the session by rating this webinar, and let us know if there are any other topics you'd like us to speak about. So now that we have the rules out the way, the floor is all yours, Patrick.
Thanks, Sarah.
You're welcome.
All right, let's get this set up here for you. Go ahead and set up my share. And there we go. So for today's talk, as Sarah mentioned, we're talking beyond observability with Unravel, so optimizing your jobs on Databricks or accelerating performance. Before we jump into that, just a little bit about myself. As Sarah mentioned, my name is Patrick Mawyer. That is me standing there in front of my sunburst bamboo, big bamboo aficionado. I am a senior solutions engineer at Unravel Data. You'll see there is my email address if you wanted to email me directly. Also available on LinkedIn under my name as well. So to kick off the discussion, first we want to think about the life of a Databricks developer. So I'm sure everybody has a developer that looks just like this guy, sits in front of a giant monitor with a lot of little sticky notes, throwing his hands in the air, asking all these questions. Why did my jobs fail? Why is my job running slow? Did I choose the correct driver, worker types, talking to my infrastructure team? Should I use auto scaling? Am I having a problem with my cloud provider? So a lot of questions that a developer might go through in his head. Databricks jobs, they're complex. Making them reliably faster is hard. There's some questions you ask. Is my job configured properly? Considering the number of nodes for your cluster, the instance types that you want to use, the Spark time that you've coded for, or the Spark runtime that you've coded for. Are you allocating resources efficiently, making efficient use of your RDDs, auto scaling? Perhaps, do you want to use reserved instances if you're doing, for example, something like an interactive cluster? Or is it a code configuration? Your Spark configurations, if you're having data skew or task skewing when you go to run your job, or maybe you're having resource imbalances, that could be the result of skewing activities, or maybe shuffle inappropriate resource utilization. There's a lot of different things that can impact your application running in Databricks. And if you leave that unchecked, it's going to have an impact on your teams, or at a larger scale, the entire organization. And it's going to manifest in things such as time that you lose for the actual development work, unnecessary waste of your resources, which ultimately is going to cost money. You're going to have missed SLAs, jobs not running as fast as they should, and ultimately failed projects, which can do things such as impact revenue streams or cost the company additional money. So when you want to optimize your jobs, you're going to have monitoring solutions in place. So there's a few options out there, starting with out-of-the-box monitoring solutions. In Databricks, your out-of-the-box tools are going to include the Databricks UI. So from here, you'll be able to see what clusters you've spun up in Databricks, DBU usage, that sort of information. We want to talk about specific jobs. The information there we can get from Spark UI. It's our second interface. Look at the jobs, look at the stages of jobs, tasks, get some general skewing, quartiles, Spark logs. In this case, I might want to go look at the logs for my jobs related to the driver, related to executors, This is my third interface where I'm going and I'm collecting information. Now, when we take all of that together, we're covering, job metrics, resource usage in the Spark context, and then there's our stack trace that we can get from logging. It is a more modern interface, we'll say, and it's plug and play because it's part of the platform. But you'll notice there's other components here missing, such as network metrics, host level metrics, and then going further down into proactive code level insights and configurations for your clusters. Now we can introduce an open source of Ganglia, which comes with Databricks. This is going to address some of the infrastructure metrics that we have missing. So you'll see things from a cluster level, specifically at a node level. And what that's going to allow us to see are host level metrics. So our CPU consumption, memory consumption, disk usage, network I/O, all things that can impact the performance of your job. What can you do with the insights? Well, understand if your nodes are properly allocated. You can change instance type decisions on requested resources. You can base a number of nodes or your auto scaling initiatives or policies on requested resources. And you can understand if you have any kind of network or I/O related issues with your jobs. But there's limitations. In Ganglia, it's going to be point in time or essentially a snapshot based. I don't really have a great historical context of what was going on. There's not a great output for this. I'm not going to be able to take this and drill down into it. It's just a JPEG output of what we see at that point in time. Data is not going to exist, as I mentioned. There's not a whole lot of historical context, so short shelf life. And as we've seen between Databricks UI, Spark UI, Spark logs, and now Ganglia, we have 4 different tools that we're trying to correlate to try to get insights. I mentioned Ganglia is open source, but if we think about the open source projects and where the community support's going, starting to shift more towards a modern observability platforms like Prometheus. Prometheus is making great penetration and with the success of Kubernetes. So a lot of the shift is towards that. So you're losing support from the Ganglia standpoint. And Prometheus isn't included with Databricks. But if we take Ganglia and we add that on to what we have with our Databricks UI and logging, we complete a little bit more of the picture, adding in those host level metrics, network and disk usage, but we're still missing proactive code level insights and configurations. There's other monitoring solutions. You got your cloud providers, things like CloudWatch, Azure Log Monitoring and Analytics. But with cloud native monitoring tools, you're going to have to consider a few things. One, primary audience for those tools are typically classic web applications or things that are more related to their platform. They're not plug and play ready. There's going to be some development effort, some integration that you're going to have to build with Databricks to really get great insights from those platforms using the cloud native tools, which ultimately leads to a cost to maintain. And a lot of times they are only really focused on cloud, their own cloud native services. Again, if you wanted to integrate that with things outside of the cloud native services, more work's going to have to be done. So you got a vendor lock-in consideration. So there's other tools, third-party observability platforms, Datadog, a common example that we see out there. And this can give you some Spark context and some infrastructure metrics in a single platform. It's an easier to work with interface, pulls similar metrics to what we talked about before. It does provide some APM-centric insights, could be useful for further understanding issues. But it can be expensive. And in a lot of cases, it really only makes sense if you're already an existing Datadog customer or whatever APM you happen to be using. And just like what we've mentioned before with the cloud native, these are rooted in classic web monitoring and observability, more traditional applications, not your data pipelines. So we add that to the stack, and it really doesn't add any additional coverage. It just sort of consolidates into more of a single platform, what we've already discussed. But as you see, missing proactive code level insights and optimizations and configuration level optimizations. So what if there was a tool that could provide insights from the cluster all the way down to the tasks? Proactive intelligence built in that helps bring more insights, brings recommendations for those optimizations. Easy to use with a modern interface, and cloud agnostic, so I'm not tied to a particular vendor. That's Unravel. So we bring Unravel in to the stack here, and you'll see addresses all the features we discussed before, as well as now proactive code level insights and configuration level insights. Now we have customers that have had great success implementing Unravel, 8451, an arm of Kroger, Cox Automotive UK, many others seeing significant improvements with their implementations. And if you want to go check out the stories in more detail for yourself, I highly encourage you to go check out unraveldata.com, resources, customer-stories, or if you're at our website, unraveldata.com, just click the learn at the top and go look at the customer stories from there. Now, what does the platform actually look like? How do we accomplish what we want to do in optimizing our jobs? So this is the Unravel platform. You'll see at the top, right off the bat, operationally speaking, we're going to be able to track all the clusters that have been spun up for jobs, or if you have interactive clusters maybe actively running. We're going to see all of that, resource usage and memory. So one, understand if you're, say, over allocating resources for your clusters, probably an indication right off the bat that things aren't optimized. But furthermore, very quickly, you're going to see where we're going to group your inefficient Spark applications by various events that we detect in those applications. So very quickly across the board, you're going to be able to start seeing grouped inefficiencies. It's going to give you some insight on where you can get best bang for the buck and going and triaging and optimizing your jobs. The other way you can go and do this is going to be through applications. So if we jump in here, we're going to be able to look at clusters, either automated or general purpose, interactive or job. Typically, you're going to be running automated clusters or job clusters because you're going to want to have scheduled jobs, and that's where you're going to be doing most of your production workloads. But also from here, you'd be able to look at, what jobs do I have? Essentially pipelines, like I may have multiple applications that run as part of these jobs, but then I see job runs, and this is where I can see the actual instances of executing those applications. I'll be able to see at a quick glance, where these are running as far as instance types or Databricks instance types, the workspaces they're running in, which cluster in that workspace, and ultimately, what was my DBU utilization for running this? Now, if I want to look into a particular job and start to figure out, where can I do some optimization? We're looking at this job here, running about 13.3 DBU and ran over a course of 3 hours, 37 minutes. Let's go ahead and drill into that and see what insights we might have. So you see right off the bat when I jumped in here, Unravel is already providing a recommendation to improve application efficiency. I haven't even looked at data yet. Fact of the matter is, you have an expert in the box with Unravel. It's already analyzing all the data behind the scenes for each and every application execution. It's going to be able to surface these recommendations utilizing artificial intelligence. But you'll see all of the information that we talked about that you could get from those various UIs, log solutions. It's all being aggregated into one centralized interface here. So I can see information about the job, how long it ran, all the way down to the number of tasks, and we can drill down and look at the details on that in a second. But what I wanted to highlight here is we're surfacing these events. And you'll see, as I mentioned, one recommendation to improve app efficiency here. Well, that recommendation is pointed out clear detail. It's what we currently set for our broadcast threshold. Here's our recommended value based on all of the data that we pulled in. Now, typically, what you're going to see is some algorithm or some formulas that are going to be back of the paper math, and you're going to have to understand, you know, how many nodes do I have? How many cores do I have? Partition and memory. You know, there's a lot of things that go into trying to figure out how I want to set things to run my job. And there's a lot of trial and error and a lot of calculations. That kind of stuff is being done behind the scenes. And then we're able to surface these type of configuration details to help you improve efficiency without all that extra effort that you'd have to put in job by job. From an efficiency perspective, we can also look at, as I mentioned before, you know, instance types that you might have in play. Now, this isn't necessarily optimizing for performance, but it's optimizing for cost. And it's something that's important because ultimately, the money you save here, if you need to address performance by increasing resources on another job, instead of just throwing more money on top of the pile, you can repurpose that money from making some of your other jobs less costly. Now, we talked about here recommendations to speed up the application. So this is talking performance, and this goes back to that recommendation on changes that we'd want to make. There's also going to be other recommendations that we might make for you in terms of improving how your data is set up or how you've partitioned or potentially even data from a standpoint of what types of configurations you're using there. You'll also see we pointed out low utilization of Spark storage memory. So what we're going to have here is, you know, if we're seeing that memory is not being utilized efficiently, you might be able to then take advantage of things such as caching. Caching will allow your application to run faster and make better use of the resources that you have at play. So that's another recommendation that we happen to have surfaced here. Now, if I want to go in and see all the details, sort of the information that we're acting on, we see here for the application, I can look at some program related information, query plan, the program that was executed. We can also see things such as running containers. This can come into play if I'm considering auto scaling or how I'm going to auto scale when I run my jobs, because I may see, for example, in this case, it's pretty static. I have a certain number of containers running from beginning to end, but I might see scenarios where I have containers, say, running at 3, scaling up to 5, maybe scaling back down. And there could be wait times associated with that that's impacting how long it takes for my job to execute. Now, if we see that here, that gives you some insights into considerations for how you may want to auto scale or maybe not auto scale. If I'm just going to scale right up at the beginning, I might want to account for that and just make it static. You can also look at resources from here very quickly, understand resource utilization related to my driver, as well as all the executors that were at play. So I may very quickly see from here where I have most of my work being done on my driver versus my executors, and I'll see a flip-flop in this graph. And by the way, we're likely going to surface that up here in our events anyway, so you wouldn't even have to hunt that down. But we're going to give you resources related to the JVMs, the OS, the system itself, so you can quickly jump around in here, and I can do this as a developer. I don't have to be reaching out to an infrastructure or platform engineer to get me that information. And then if I want to see where my application is spending most of the time, to give further insights. I can see that here with this wall clock, and I can see if my application is spending most of its time in input, output, or processing. So in this case, we're seeing a lot of time being spent on input. But as we saw, if we make use of caching and broadcast threshold, increasing that, we can cut down this input time significantly and spend more on processing, ultimately speed up the application. Now, if I want to drill further down into my Spark application by job, we see all the various different jobs here, and I can sort these. If I want to just focus on the ones that are spending the most time, I can sort on duration. If I click on this particular job, this is going to expand me down into the stages for that job. And again, I can see, what stages am I spending the most time? And if I want to drill into that, this is going to give me a further breakdown of where my time is being spent with all my tasks running in this stage. So I may be able to find information in here, such as if I'm spending too much time in garbage collection because I'm having memory configuration concerns, or if I'm spending a lot of time in shuffle. I might have skewing issues where if I have, shuffle that is most of it's happening over here in a smaller time frame, but I have some shuffle that's taking a long time, I would be able to see that here. But again, we're likely going to determine that up front and already have surfaced that up to the top in that events for you that you're having task skew. If I want to see specifically all those tasks and I want to narrow in on just a particular grouping of that, I can do that here and then see specific task related information and what executors those tasks run on, because I might have something related to a specific executor and configurations there that are impacting time. Now, if we go back and look at some other applications here, maybe we're having issues with our applications failing. And let's grab this one here. If you have tuning suggestions, typically you're going to see that icon very quickly and be able to target those without having to search too hard. We're going to come in here and we're going to look at this particular failed application. And as the name suggested, it's likely memory related. We have 3 insights for this application that we want to point out. And if we come in to these events, as we usually see, there's going to be a cost recommendation for instances. In this case, it's both driver and worker. Well, what's more importantly, we come down here and we see things like the high garbage collection overhead. So as mentioned before, you could drill all the way down and potentially find where garbage collection is really high related to a particular stage, but we've already surfaced this for you, and then allow you to drill down into your specific executors that are having that problem. So we're going to identify that up front. And then again, maybe not specific recommendations on go change this configuration, but directed information on where to go look for correcting this information or get further insights. So we can point you to specific metrics that you may want to look at related to the executors in this case. We also, in this case, point out contention with driver. So driver in this case is spending most of the time. So if we wanted to see that, we could actually come over here and look at our resources and actually see that in play. And we have our drivers up higher than it probably should be. Now, the other thing that you're going to find in here that will help you optimize your jobs is going to be in the case of logs and errors, which I don't seem to have any in this. Let me see if I can grab a better job for you. In this case, we're actually looking at a workflow that's got multiple jobs running in it. So we go in here. We do not have any errors in that either. This is live, folks, so bear with me. See if I can get you a failed job in our demo environment. It's got some errors in it. Another thing we pointed out here, large idle time for executors. So we might want to, as I mentioned before, point out some things such as increasing number of partitions, make better use of the resources on your executors, make that job run faster. But if I come in here, you'll notice, okay, so this is where we got some correct information in our demo environment. So we're going to collect the logs. This is all pulled into this interface relative to this job. I don't have to go hunting these down, but we're going to parse these for you already and bring this up and look at any warnings, errors, or most importantly, your fatal exceptions. Quickly called out, we can see this, it's coming from the logs out of memory error. Otherwise, you'd have to be diving around through each of the logs trying to figure out what happened. So very quickly, you see that here in this interface pertaining to this application. So that's how we could quickly drill down and get information around failed jobs versus just focusing on optimizing successful jobs, which is an important point to make, that just because jobs are succeeding doesn't mean there's not room for improvement. It's essentially a hidden cost or a hidden problem, because success that, hey, I've passed, I've run successfully, everything looks green. Our AI is going to surface up these events, make it very easy for you to find these, and then optimize those jobs. Now, the other thing you might see that could potentially manifest itself in causing problems in your Databricks environment is going to be things related to your operational insights. Very quickly, we can look at usage trending and be able to see, if we have users that are submitting too many jobs. This becomes really important if we're talking interactive clusters too, right? If I have a user that's abusing my clusters, submitting a lot of jobs, incurring a lot of cost, or utilizing a lot of DBUs, we're not necessarily optimizing a job at this point, but it's giving us now an upfront indicator of where we could potentially go to look at either optimizing those jobs or at least optimizing our clusters and how they're being used. So that's another thing that you can do here within Unravel. Now, the other thing I'll mention is this is not just for a single Databricks instance. We can look at this across multiple Databricks instances. So you're going to have that visibility available to you. So utilizing all that information, the AI that we apply to your various running applications, this is how those various organizations that I mentioned earlier have been able to make use of Unravel and very quickly identifying areas of potential improvements that they can make, and then giving those recommendations up front, insights that you would otherwise not get immediately provided to you. So we can shave hours per job optimization that's going to translate essentially to save money for your business. So with that said, I think we can go to questions. If there's any questions out there. And actually, while we do that, I'm going to bring up one other thing just so that you have this, just to reiterate what we spoke to in summary. So really what we talked about, ensuring jobs are adequately resourced, ensuring that you have optimal code quality, you're reducing your mean time to recovery is typically MTTR, but let's talk about it as MTTO, mean time to optimize for your slow or failed jobs and pipelines. And then, ensuring that your ROI is appropriate by understanding those usage trends that we talked about there at the end. And I'll go ahead and point out that you can do Unravel for yourself. We do offer a free trial if you go to unravel.com/SaaS free trial. It's very simple to go and get that started. And with that said, now we can open it up for questions. Do you have any questions out there, Sarah?
Yeah, let's, there we go. Okay, so first question we have is, does Unravel work on all cloud providers offering Databricks?
Yeah, so as I was sort of pointing out there in the platform, in that dropdown, you can see that we support Azure, Databricks. There's Databricks on AWS, and in the very near future, we will be supporting Databricks on GCP. That's a new offering that they have out there. So all the major cloud providers, for the most part, are going to fall underneath of our support. So good question. Thank you.
Oh, we have another one here. Said, how does this tool help with self-service for data scientists and app developers?
Yeah, so the self-service aspect, if you think about what it was that we were just showing, all of that information that you would normally have to go and find, you'd either have to ask an infrastructure person or maybe somebody like that's managing the platform itself. There's a lot of different areas that you'd have to go. It's going to also add overhead if you're going to have to give access, if you wanted to give the developers self-service in that kind of model. There's a lot of points of access that would have to be set up. So what we're doing in our platform is we are pulling all of that information into one place. So the developer already has that available to them, the logs, the metrics coming from the various APIs or UIs. And then we're also going to be providing those insights and recommendations. So the other thing too is a lot of times we find where companies will have a support contract with Databricks, or maybe they're going to some other service provider that's going to help them optimize their jobs. And that's just really a human on the other end of that discussion, doing the same thing that otherwise a highly skilled developer would have to do in-house. So now I don't have to be an expert in Spark or an expert in Databricks to be able to get answers. And I don't have to go to other people to get those answers because I already have basically my expert assistant living inside the Unravel world, working alongside with me. So that's how we provide the ability for developers to have self-service in that perspective.
Great, thank you. Next we have, how does Unravel install in my Databricks cluster?
Unravel in the Databricks cluster. Okay, so there's a couple different ways that we can work with that. There's the SaaS trial that I've mentioned, or a trial, but ultimately you could just continue to run that in SaaS, and that's just spin up the account and connect it to your workspace, and then as clusters get created, we're going to inject as part of that. We'll have a daemon that runs, and then the jars that get injected in with the jobs as part of the JVM collects data. But it's a pretty quick and straightforward setup process. If you wanted to run the whole Unravel server on-prem or in your VPC, let's say, we have a download and install that you can do everything housed in your network. You control everything beginning to end. We don't have access to any of your data. The other thing I can point out here, as far as what that looks like from a sort of an architectural standpoint, let me bring that up for you real quick. So this, in general, is your Unravel for Databricks architecture. This is that server I was talking about, or you can have this spin up as that SaaS account. But ultimately, from there, it's really just this Unravel daemon gets put into your cluster in your workspace. And then these Unravel sensors is what's actually goes in with the JVM when you're running Spark application, reporting back code level information. We're going to collect also logs from DBFS as well as from the control plane. This is also the sort of that UI stuff that we're talking about. And then bringing that all in and aggregating it, whether this is your SaaS application or the server that you're running on-prem. So that is what it would look like in relationship to connecting to your Databricks workspaces. Good question. What else do we have? Any other questions out there?
Yeah, I see one more.
Okay.
It says, what data are you collecting from Databricks into Unravel?
Yeah, so it's a question we actually get a lot because I think some people, it's big data. There's a lot of data. There's a lot of important data, and probably data that you don't want a bunch of vendors looking at. And so we're not worried about your sensitive data or things that are more granular detail of what you're processing. What we're looking at is metadata related to your running jobs. So, we're analyzing the code that's processing your data, but not the data itself. We may be looking at things like file sizes, how a file is partitioned, or what's the format that you're using. But again, we're not looking at the specific data inside of that file. We are collecting the logs. We are collecting metrics from the various APIs and that sensor data related to your code. But again, nothing that is sensitive to your business. Now, if there is a concern, right? So I mentioned, and we have companies that go this way. We have the SaaS offering, but if data sensitivity is a true concern, you can't get around. Some companies will say absolutely no SaaS. We're not letting anything leave. That's why we have that on-prem deployment model. We don't even have connectivity into that. If we want to support you there, we are jumping on a call, working with you, and you're going to share your screen or provide the information to us. So you have that safety measure and that deployment model if you so chose to go that direction. So another good question. Thanks. What else?
Actually pretty related. Someone asked, how does Unravel fare with security compliance? Does Unravel just access Databricks logs, or does it access customer data as well?
We are not accessing customer data. It's just stuff related to the job execution in terms of, I want to understand how the job is performing. I don't necessarily care about what the details are of what the job is processing beyond things that would impact performance. And we are SOC 2. I guess I'll throw that out there if anyone's curious about that.
Okay, does anyone have any other questions? If so, you can put it in the chat. Okay.
Cool.
All right. So that's it for today. But this webinar is also available instantly on demand, so you can feel free to watch it again or share it with colleagues and peers via the same web address as you logged into this time. And if you're watching on demand and you want to ask questions, feel free to email us at hello@unraveldata.com. And again, you can let us know what you think about the session by rating the webinar, and let us know if there's any topics you'd like to hear about. Thank you so much for taking your time out to watch. And thank you so much, Patrick, for sharing your amazing knowledge today. And then keep an eye out for our next Optimize webinar on accelerating performance for Amazon EMR. So thank you, everyone. Thank you, Patrick.
Bye.
Bye.